In this video, we are looking at nested and complex models in FastAPI. Real-world data is rarely flat. An order has a customer has an address, and an address has its own fields. We will see how Pydantic and FastAPI let you express that naturally, and how deep validation happens automatically without any extra effort on your part. Imagine your API receives an order that contains a shipping address and a list of line items. If you accept that as a plain dictionary, you have to manually dig into nested keys, check types at every level, and repeat that logic across every endpoint that touches orders. One missing key or wrong type, buried 3 levels deep, silently corrupts data or crashes at runtime, exactly the kind of bug that is painful to track down. Here is the mental model to hold on to throughout this video. Think of Russian nesting dolls, where every single doll, even the innermost one, carries a label that says what shape it must be. When you open the outer doll, Pydantic checks its label. Then, it opens the next doll and checks that label too. Validation happens at every layer automatically, so you never have to write that checking logic yourself. Pydantic lets any fields type be another Pydantic model class. You define a small model for an address, another for a line item, and then reference those types as fields inside your order model. You can also annotate a field as a list or a dictionary of models. Pydantic will iterate over every element and validate each one against the inner model's rules, reporting precise errors for exactly the field that failed. We define 3 models. Address holds street, city, and postcode. Line item holds a product identifier, a quantity constraint to be at least 1 using field with GE equals 1, and a unit price that must be greater than 0. Then order references both. Shipping address is typed as address, and items is typed as list of line item. The atap.post decorator registers the endpoint, and the function receives order already fully validated, every nested field checked. Inside the function we compute the total by iterating over order.items, which are guaranteed to be line item instances, and return a plain dictionary that FastAPI serializes to JSON. When a request arrives, FastAPI reads the raw JSON and hands the resulting dictionary to Pydantic. Pydantic does not just check the top-level fields, it recursively instantiates each nested model in turn, running every validator along the way. If the postcode is missing, or a quantity is 0, Pydantic returns a 422 unprocessable entity response that names the exact field path that failed, like items.0.quantity. Your OpenAPI docs also reflect the full nested shape automatically, so clients know exactly what to send. Nested models shine when your data genuinely has structure. A shipping address really is a separate concept from an order, and it may be reused on a customer profile endpoint too. But nesting for its own sake is a trap. If your payload is 4 flat fields, wrapping them in 2 extra models makes the code harder to read, and the errors harder to understand. Also resist the temptation to mirror your database ORM layer one-to-one in your API models. The shapes your database needs, and the shapes your clients need, are often intentionally different. The core takeaway is simple. Nesting in Pydantic is nothing more than using another model as a type annotation. From there, FastAPI and Pydantic do all the recursive work, validating every item in a list, every value in a dict, every field at every depth. Keep your models small and focused, compose them into larger shapes as needed, and you get deep validation, clear error messages, and accurate API documentation with almost no extra code.